Hello learners. In the previous session, we have discussed about the web analytics, then how the web is being used for displaying the advertisements and how the revenues has been generated by displaying the advertisement, how the selection of the advertisement is being done based on the AdWord algorithm or the balanced algorithm. So in this session, we are going to discuss the other areas related to web and the social network analysis. So one of the important area of the web is recommendation systems. Now, what is the recommendation system? A recommendation system is a class of machine learning that uses data to help predict or to narrow down and to find what people are looking for among an exponentially growing number of options. So a recommendation system is an artificial intelligence or AI algorithm usually associated with machine learning and that uses big data to suggest or recommend additional products to the consumers. These can be based on various criteria including past purchases, search history, demographic information and other various factors. Recommender systems are highly useful as they help users discover products and services they might otherwise have not known on their own. Now, how these recommendation system helps? Recommender systems are trained to understand the preferences, previous decisions, characteristics of people and products using data gathered about their interactions. These interactions includes impressions, clicks, likes and purchases. Because of their capability to predict consumer interest and desires on a highly personalized level, recommender systems are a favorite with content and product providers. Now, they can drive consumers to just about any product or service that interests them, from books to videos to health classes to clothing to food items, any. So why we need this recommendation system? Here in the diagram that we have seen, user can buy the smartphone, can like a particular song, can watch a particular movie, dislike a movie, can buy camera. So there are multiple applications that a user can build on the online platforms. From all these platforms, the recommender system gets the feedback, which is called the user feedback, and maintain that feedback, analyze those feedbacks and then provide the recommendation list to the user next time when it is going to buy a smartphone, going to play a song, going to watch a particular movie and then buying some other products such as camera. So for example, a particular user is going to buy a TV and is not sure about the size, type and brand of that particular TV, and there are a very large number of choices related to sizes, types and brand exist. So now that particular user is confused which one is to buy and which one will suit. So in such situation, he or she would like to consider impartial advice. So this may be the reason the recommender systems were created. So why these recommendation systems become popular? This can be attributed to the web-based marketing of the products. Here in the right side in the graph has been plotted between the sales of a product and the product in the order of sales. So common products are being purchased on regular basis, but there are some long tail products which are not that particularly high demands. So in direct marketing, the shelf space of the store is very important, but as the marketing moves to the web, a very large number of similar products can be sold, leading to marketing of choice. So these long tail products can be sold using the recommendation system. So what is this era of the digital market? A large number of products are on sale. Some of these products sell at a very high rate, but most of the products have a low demand, which are called the long tail product. So these low demand products are also very large in numbers and can be of very good quality and are termed long tail products. Only those products that were selling the most were finding a place on the shelf and were being stocked. However, in the digital market, even the products which have low demands can be sold, as they need to be stocked at all locations but can be made available on demand. So these long tail products are now available to journal users. For example, suppose you want to buy only album of classical music. Then earlier, in the case of the shelf market, you have to find out the store which used to sell them, which is very difficult to find. So now you may be able to order them easily. In addition, suppose you order some such system using the digital market, then based on your choices, it is possible to suggest to you some other classical albums that you may find interesting. This is the advantage of recommender system. Now there are various other applications of the recommender system. These systems can be used for recommending books, music album, movies, published articles, etc. A recommender system of books found that several purchases of a book, say a book named X, also purchasing not a very popular but high rated book Y. So the system started showing this book as a recommendation to the purchaser of book X. It turns out that after a while, even book Y become one of the best seller, because every user who is purchasing X, the recommender system is showing you may also like book Y, which is so and so rating. So customer B has also starting buy the book Y. So the rate of purchasing of book Y increases and it has become the bestseller book. Thus, recommendation system applications have great potential, as they can inform purchasers about the availability of some good items which were not known to them due to the very large number of items. So there are various types of recommended systems are available. Here we are discussing about the 3 recommending system: recommendations by editors, critics or the staff. The second is aggregates recommendations. The third is user specific recommendations. Now what is recommendation by editors, critics or staffs? This is the simplest kind of recommendation system which are in existence from a long time. In such system, recommendations of editors or critics or staffs are recorded and reported. One of the major weaknesses of such systems is that it does not take input from the actual customers. Next is aggregates recommendations. As the diagram shows, there are multiple users which are dealing with the recommendation system, and there are items, those are grouped. For these items, the feedbacks from all the users has been taken and are aggregated. So such information is aggregated from the various users or customer activities. For example, the most popular video or the most purchased product or the highly rated services, etc. However, these recommendations may not suitable to a particular user requirement, as these recommendations are generic. Then another types of recommendation is user specific recommendations. Here these recommendations are specifically being made for a specific user based on his or her past web activities such as online purchases, searches, social media interactions, viewing of video, listening to audio, etc. The recommendations can also be done by the behavior of the similar users. For example, a particular person has watched a movie and another person has also watched the same movie, then the another movie watched by both of them can be displayed to each other for one of the recommended video. Now, the problem of user specific recommendations, for example, say a set of users or customer S who has given some rating to some of the product or services. So a set of product or services, say P, being sold or provided by the web applications. A set of ratings for every pair of customer and product. These ratings may use a star rating scales of 0 to 5, or say from 0 to 10, or just 0 for showing dislikes and 1 for showing likes. It may be noted that the values of 0 to 5 or 0 to 10 are ordered in terms of liking a product, with 5 or 10 as the case may be the liking being the highest level of liking. So these ratings may be represented by using a model or as a function, say function f, which is making a relation between user and the product which are providing the rating R. So this mapping can be presented using a utility matrix, which is a sparse matrix, and here has been shown as a two-dimensional matrix. In the rows, the customer has been shown, and in the columns, various product has been shown. So here 5 products has been shown from P1 to P5, and there are 3 customers who has rated those 5 products. So C1 has rated P1 as 3, P2 as 1. It has not rated P3 and P4 and rated P5 as 2. Similarly, C2 has given a ranking 4 to product P1 and a ranking 1 to product P4, and customer 3 has shown the ranking 1 to P2, 5 to P3 and 3 to product 5. Now, what is the objective of the problem? The objective is to find the expected rating that may be given by a customer S to a product P which he or she has not rated based on his or her other ratings. So the output is the customer specific recommendations based on the computations of expected ratings. So the key problem of making a recommender system is gathering the ratings into a utility matrix. One of the simplest way of gathering the rating would be directly ask the customer to rate a product. But however, since the customers are very busy, very few people spend time to rate a product. Therefore, in addition to this direct rating, most e-commerce websites implicitly rate their product. Now, how the website can implicitly rate the products? So, consider a case where a customer returns a purchased item, which means he rates the item lowly. On the other hand, a purchased item may get a good implicit rating. An item which is purchased again by a customer should be given a high implicit rating. A utility matrix may contain both direct and implicit rating given by a customer. Second is computing the unknown rating for every customer. The focus here is to find the high unknown rating only, as you would like to recommend a product to a customer only if he is expected to rate it highly. So the key problem is finding the unknown rating is that the utility matrix is sparse. So in addition, a new product has no rating when added to the list. There are 3 different types of approaches to computing a rating system. One is the content-based approach, second is the collaborative filtering, the third is latent factor-based approach. So we are going to discuss content-based approach. So the key problem of making a recommendation system is evaluating the performance of the recommender system. How we will evaluate the performance? One of way of computing the performance of a recommended system is based on the fact that a recommendation has resulted in a successful purchase or not. So as the diagram has been shown here, in the center, recommendation component is there, which is collecting the input from the various product in the form of the product features, and it is getting the input of users, which is containing the user profile and their various contextual parameters, and it uses the knowledge models to identify the recommended products to the user depending upon the user's parameters and the product features, and it prepares a recommendation list. Now out of this recommendation list, if a customer is going to buy one item that is mentioned in the recommendation list, then we will say that the recommended system performance is high. So content-based recommendation. What is content-based recommendation? This recommendation is designed to recommend a product or service to a customer based on his or her earlier high-rated recommendations. Example of a content-based recommendation system are the recommendations of movies, search articles, friends, etc. How it works? See, it starts from the customer, then it records the customer liked products or the services, then make a profile of the product or services that customer has liked earlier. Then it makes the customer profile, and depending upon these two, they recommend products or services to the user. For example, if you highly recommend a movie, then a content-based recommendation system is likely to recommend movies of similar actor or genres, etc. Similarly, if you highly rate a research article, the content-based recommendation system will recommend a research article of that particular author or research article of similar content or similar nature. Now, how this content-based recommendation system works? Firstly, the product, it captures the profile of the product or the service, which is defined with the help of a set of features. For example, the feature of a movie can be in the form of actor, genre, director, etc. Whereas for research articles, these features may be author's title, metadata of research articles, etc. The accumulation of these features makes the customer profile. Another side, we maintain the product profile, which is represented using a set of vectors. To represent a movie, these set of vectors will be name of actors, name of director, and type of genres. For research articles, we use the term frequency and the inverse document frequency, and generally we used to mention these as TF, IDF, where TF represents the term frequency, how frequently that term is occurred in that particular research article, and inverse document frequency means how many number of documents, in how many number of documents that particular term has appeared. Let us consider an example to understand how recommendation system works. So we are taking an example of recommendation system of movies. Consider the only feature that we are considering here, the genre of the movie, and assume that movies have just two genres, X and Y. A person rates 5 such movies, and the only rating here are likes or no ratings. So in the table, we have shown a simple utility matrix where 7 movies are there in the form of the columns and the rating of the customer Z. Here customer has rated M1, M2 and M3 are of genre X and M4 and M5 are of genre Y. Again, we have shown this utility matrix in the form of a product feature matrix where only 5 movies has been considered which users has rated, and the genre as represented as 2 rows. So for M1, M2, M3, X row has 3 ones and for M4 and M5, Y row has 2 ones. So this product matrix now can be used to produce the customer Z profile. Feature genre X profile is sum of the row of X divided by the movies rated, which is equal to the 3 by 5. Feature genre of Y profile is 2 by 5 because 2 movies has been rated in Y genre. However, in general, the customer rate the movies on a scale of say 1 to 5, with 1 and 2 being the negative ratings, 3 being the neutral rating, and 4 and 5 being the positive rating. So, the movies for which there is no rating has been done filled with NR, where NR means not rated. So, considering the same product feature matrix, in general, on a scale of 5 point, each customer has their own way of assessing these ratings. So, customer Z has rated M1 and M2 as 1, M3 as 2, M4 as 4 and M5 as 2. Therefore, how we assessing these ratings? So, there is a problem. So, we have to normalize the rating of each customer. Now, how we can normalize this rating? For that, first find the average rating of a customer. These customer has rated 5 movies with an average rating of 10 divided by 5, which is equal to 2. We have just computed the total of all the ratings and divided by the total number of movies that has been rated. Next, use this average rating, which is 2, to mean the neutral rating, and subtracting it from the other rating would make the rating as -1, -1, 0, 2 and 0. Because for M1 the rate has been done 1, for M2 it was also 1, for M3 it was 2, for M4 it was 4 and for M5 it was 2. So, to generate the customer Z profile, feature genre X movies, sum of normalized rating of genre X movies divided by the movies rated of genre X, which is equal to the normalized rating of M1 plus M2 plus M3 divided by 3, which comes out to be -2 by 3. Feature genre Y profile, which is equal to the sum of normalized rating of genre Y divided by the movies rated of genre Y, which comes out to be normalized rating of M4 plus M5 divided by 2, which comes out to be 1. So, the customer Z has a positive profile for genre Y. So, this is how the recommendation system works to find out or to does the prediction of the recommended list that product or that services can be recommended to the customer depending upon the customer profile, and while accessing the customer profile we are considering the product feature matrix. The next related issues for the web is mining social networks. As all of us know that how the social networks are growing, each and everyone is connecting from another person on the social media. For example, friends on Facebook, Twitter, Instagram, WhatsApp, Pinterest, Spotify. So these all are the various social media which through which we are connecting from one to another, and all these medias are using the recommendation system by accessing the users' profiles. So social media has an immense amount of data about people's interactions among themselves. This data can be processed to produce useful information about certain products, services and communities. Now, this data is obtained from the social media networks such as Facebook, Instagram, Twitter, LinkedIn and many more. YouTube, Insta, Pinterest, Spotify, Snapchat, there are number of. So the key question here is related to the social media is to find the communities. What are these communities? Communities is nothing but a subset of related groups from amongst a very large number of people. For example, a group of your classmates of the school as one community, a job related group as another community. One of the characteristics of a community is that people of one community may know each other and possibly share the same interests. However, they may not know the people of other communities. Then, what is social network? We can represent the social network as graphs. Social media networks consist of large number of people, their interactions, their connections with other details. Social media network can best be represented with the help of a graph where each node represents a person and a link represents the relationship of that person with others. On the right side of the screen, we have shown a social media network graph where three subsets are shown: college friends, working with, and the family. Each node, each circle, small circle is showing a particular person or people, and the edge or the line connected with the other people is showing the relationship. So these links can be undirected or sometimes maybe unidirected. Now there are various varieties of social networks available. Most of these networks are used for sharing personal or official information. Traditional social networks, these are used for sharing information among communities of friends or people who come together for a specific purpose, primarily analyzed for getting information about groups. One of the example is the collaborative research network. Such a network includes links among authors who have co-authored a research paper. One of the communities of this network is the editors of the research work. These networks can be used to find researchers who share common research areas. Another example of the social network or another variety of social networks are social review or discussion or blogger network and image or video sharing networks. So first, social review or discussions or blogging networks. Such networks create a node for the user and make links if two users review, discuss or blog the same topic or the article. These networks can be used to identify communities which have similar thinking and inclination. Image or video sharing networks. These networks may allow people to follow a person hosting a video. A follower may be linked to a host in such networks. The meta tags of videos and the images are comments of the network. Watching the video may be used to create communities that share common interest. Now, how can we find out the communities on a social network graph? So for that, as we have done on the normal graphs, we find out the similarities between the various nodes. So here we are going to measure the distance of social network graphs. For finding the communities in this social media graph, one may use clustering algorithms. One of the clustering requirement is finding the distance between the two nodes. We must define a method to find the distance between two nodes in a social media network graph. In a social network graph, a node represents a person or an entity and a link represents a connection between two entities. However, the problem here is that as the links represent the friends or connections or the relations, so it does not have any weight assigned to it. In machine learning clustering algorithm, we use the weights on the links, but here we don't have any weights. So the distance between two nodes A and B represented using dis AB is considered as 1 if there is a link from A to B, and this distance, this AB, is considered as infinity if there is no direct link from A to B. Now there is an issue with this distance measure, this AB, as this may lead to the problem when there are not direct link but we have indirect links. So considering three nodes A, B and C, with only two of these nodes pair AB and BC are connected, then this AB, that is the distance from A to B, is considered as 1. This BC, which is the distance of B to C, is considered as 1, but this AC, as there is no direct link from A to C, it is considered as infinity. But we can reach C through B, that means A can connect it to B and B is connected to C, so indirectly A is connected to C. So this may violate the true distance measures rule, which says distance of AB plus distance BC should be greater than equal to distance of AC, which is not the case. 2 is greater than equal to infinity is false. Thus the definition of distance when there is no direct link may need to be redefined. How we redefine this? The social media networks, as we all have just covered, is consisting of the very large number of nodes and links. The interesting problem here is to identify a set of community in this graph. Now, what are the characteristics of a community or a cluster in a graph? A community or cluster in a graph is a subset of a graph having a large number of links within the subset, but having less number of links to other clusters. So, one additional feature of the social media network is that a cluster can be further broken into subclusters. For example, college friends cluster may consist of two subclusters, undergraduate college friends and postgraduate college friends. Such clustering is very similar to hierarchical clustering or K-mean clustering used in machine learning. The difference is that here you are wanting to find clusters in graph and not in large data sets of points in case of machine learning. Let us consider this clustering using the example. Here the example is shown in the form of a social network graph G. The graph is noted as G. With VE, we represent the various vertices and E represent the various edges. It contains 8 nodes A, B, C, D, E, F and G, H. So, this graph represents the connections such as friends. The links are not assigned any weights. The objective of the problem is to find good clusters which maximize the links within a cluster and minimize the links between the clusters. So the process to find this is to find a set of minimal edges which when removed creates a cluster. So for example, here in this social network graph, the edges C to E and D to F will divide the graph into two subclusters A, B, C, D and E, F, G, H, which are having high number of links. So here we conclude. We have discussed the recommended system which results from long tail products. The recommended system aims at providing suggestions to a person based on his or her ranking of past purchases. These recommendations are in general recommended products which may be liked by the person to whom the recommendations are made. Then we have discussed the content based recommendations which are the specific user specific recommendations. Then we have discussed the social media network and we represented these social media networks in terms of the graphs, and these graphs in nodes are representing the persons and the edges are representing the relationships or the connections. Then we have introduced the process of clustering for social media networks so that we can find out the communities where the persons are of similar interests, make a group, or say similar views, they are making a particular communities. These communities will help the recommendation system for making the recommendations. Say 10 persons are in a group of a sub community, then if one person of that community is purchasing one item and they all are in part of a community which are having the same interest, the recommendation system will recommend the another person of that community the same product the next time. So this way the recommendations, social networks or social network communities help the recommendation system to recommend the products. Thank you.